Hi, my name is Jeff Geisinger, and this is another tutorial for DIVA for Rhino, and this time we're going to be looking at annual glare. We'll be running an annual glare simulation and then analyzing the results. And like with the other tutorials, this one is based on the reference office, which is a shoebox-shaped south-facing side-lit office, and the Rhino file for this geometry can be downloaded along with this video, and it's on the link below. So in order to do an annual glare analysis, we actually have to set up a camera view from the viewpoint of an occupant inside the building. And if you go to the file under the name views, you'll see that there's a couple of views inside this file, and go ahead and double click on row 1 west. Now row 1 west is it's a view from the closest row in the west of the west side of the office, and if I set camera, show camera, you'll see that the camera in plan view, the cone of vision is in front of the computer and sort of angled halfway between the computer screen and the south facing window. So I can enlarge this camera view. You'll see that it looks relatively zoomed in the Rhino view, but the analysis that we'll be using for the simulation is actually a 180-degree fisheye lens, and so the resulting image will actually be a lot wider. So in our previous tutorials, we looked at setting a location and as well as setting nodes and materials. We don't need nodes for this tutorial, but the materials we do need, and they're already set. And if you'd like to see how you can do these previous steps, you can check out the previous tutorials. So we'll go ahead and click on the metrics button to start this annual glare simulation. So a dialog box pops up, and for this tutorial we'll be staying with the Daylight Images tab and then moving to annual glare. But since I have this kind of highlighted at point in time glare, I could explain the sort of settings and how it fits in, how the point in time glare relates to the annual glare. So the point in time glare is essentially a visualization of the scene in Rhino, this particular camera view, for a specific point in time. In this case, the default is set to September 21st at 12 p.m. And it takes a 180-degree fisheye lens, and according to the radiance parameters, it'll analyze the luminance in the scene, and it will give you an image of visual contrast, and it will tell you the daylight glare probability of the scene using software called eval glare. And daylight glare probability is a two-part formula. It's based on the vertical eye illuminance that is present at the source of the camera, and then it also considers the visual contrast of the scene. And eval glare combines these in a formula to calculate the daylight glare probability. Now what the annual glare does is that it actually takes the results from the point in time and calculates that for every hour according to the occupancy schedule over the course of the year. So once a camera view is selected, we'll go ahead and highlight the current perspective view, and then indicate an occupancy schedule. So we'll keep the default 8 to 6 with daylight savings time. Now DIVA will actually use DaySim, an engine, to calculate the daylight glare probability, not just for the point in time using eval glare for one point in time, but actually for every hour within this occupancy schedule for the whole year. And so we need to set some radiance parameters in order to run this simulation, and we'll set the ambient balances to 4 in order to have a high enough level of ambient light inside the space, which will come more into play during subsequent tutorials where we'll be looking at shading on the facade. We'll leave the default for adaptive visual comfort, and we'll leave the defaults for geometric density and clean up temporary directory. And so when we're ready, we can click Run Simulation. And these annual simulations typically take very long. It could be over an hour to simulate. And so I'll let this run and pause the video and then come back when the results come up. When the simulation is done, an annual glare report should pop up as an HTML file in your internet browser. So this can be thought of as an annual glare map. It shows in the x-axis the months of the year, and in the y-axis the hours of the day. And you'll see that whenever glare is not present, the color of the map is shown as green. And when glare is present, according to different gradients of glare, colors are represented to show at which hour of the day and during which day of the year these amounts of glare are occurring. And the legend on the bottom shows the different types of daylight glare probability that are represented as colors on the annual glare map. And so these range from below 0.35 DGP as imperceptible glare, and when it's between 0.4 and 0.35 DGP, it's perceptible glare. And disturbing glare is between 0.4 and 0.45 DGP, and then intolerable glare is DGP with a value greater than or equal to 0.45. And so what this shows us is that from our camera point, where we can hone in on points of time in the year that might be problematic, where we would look to find ways to improve the visual comfort through whether through the design of the space, through shading, or through adaptive occupant comfort, basically saying that the occupant can move their position in the office to avoid glare. And so let's look at one specific hour of the year, for example. So the glare map starts to make sense because it's a south-facing office. You can see that ranging from about 10 in the morning to about 2 in the afternoon, we're getting the worst amount of glare. And this is happening mostly in the months of the year where the sun is at a lower angle. So we're looking at more or less from October to mid-March, and then a few hours here and there depending on the sky conditions in the spring and the summer. So let's look at a time of the year where we know that we have some intolerable glare, and we'll do a point in time analysis just to visualize this from a camera view, what this glare looks like from the perspective of the occupant. So let's look at, let's say, October 21st at noon. It looks like it's around then is when there's some intolerable glare. So I'll minimize this, bring up the Rhino file, and we still have our camera set, row 1 west. And so we'll leave that. We want to make sure we have the same camera view, and I'll go ahead and click on metrics. Now we still want to be in daylight images, and whereas we were using an annual glare map in the prior exercise to pull up the annual map, we'll go ahead and click on point in time glare. We'll leave the image quality as low quality to run it more quickly. Leave the sky condition as clear, and we will go ahead and set the date and time as October 21st at 12 p.m. as we said earlier, because that was a point of time where the annual map was indicating that there would be a high probability of glare. We'll leave the camera type as 180-degree fisheye and the camera view as current perspective view. And we could also leave the radiance parameters the way that they are for the purposes of this point in time analysis. So I'll go ahead and run that simulation. It'll just take a few seconds to run. And you can see that the resulting image pops up automatically as a TIFF image, and it's a fisheye view of the scene. And you can see that the camera is facing almost directly at the glare source, which is the window, where the sun is coming at a relatively low angle right into the window, right into the camera. And in the upper left of the image, it indicates the daylight glare probability of that point in time, which is actually a full-on, full blast, 100%, and it indicates the glare category, intolerable glare. And in the next tutorial, in subsequent tutorials, we'll look at how we can add shading in order to respond to this glare and improve the visual comfort, and we'll look at that from both annual glare as well as daylight autonomy. And just before closing, if you pull up your Windows Explorer to see where these files are located, navigate to where you have your Rhino file saved. I have it saved on my desktop, and I will double click on the reference office folder. And if you click on visualizations, you'll see that both the annual glare HTML file is saved here, as well as the behind the scenes DGP file, and the most recent point in time glare image is saved as a TIFF here, as well as other visualizations that you might have run in previous tutorials. So that wraps up this tutorial. For more information, you can look at the tutorial website and find out how to access the next tutorials, as well as how to access the Rhino file that we used for this experiment. Thanks.